Hey, hello and welcome back. This is the Ultimate Ladybug course video number 23. And before we jump in, a big shout out to my new channel member, Sydney Dubinian or Dubignon. I go with Dubinian and I hope I'm correct. Let's check this out. Sydney Dubinian, thanks a lot for joining. I really appreciate the support and I hope you find what you're looking for. And if you have any question, please let me know. You can find my email address on the channel page under channel information. Now, without further ado, we jump into our course. And for that, a quick reminder where we are. So you can find the course on the playlists, and we started a while ago and we went through weather data, heating, design days, wind speed profiles, the UTCI. This is the outdoor comfort with only the weather data, without any 3D model. That very important, because we will now continue on the outdoor comfort, but with the model. Adaptive thermal indoor comfort and so on. We looked at thermal comfort with, can we estimate the required clothes we need to wear, which was quite interesting. Up to sketching, that was not really part of that. It was like a bonus video. But yeah, up to view analysis, where we pretty much covered everything. And now somebody wrote me in the comments, can you do this tutorial on LadyBug 1.8? And he meant outdoor comfort video I did in the past, which used the LadyBug 1.1, and we will, yes, so that's exactly what we're gonna do. We look at our current model, our current 3D model, and we build the outdoor comfort model with the LadyBug Tools 1.8. All right, let's jump in. So this is our model. As you remember, I built this like it's a farm, and it's still very simple massing. There's no design yet done, really. It's just really explaining what LadyBug can do. And we will open our previous file where we modified the weather data. All right, so very quickly as a recap, we imported the weather data. You can go back into the playlist to really understand what we did here. But you only need a weather data and you need this tool. You don't need to work through these adjustments I did on the weather data, because the weather data we use is very far away from the location. It's also a different altitude. So I try to modify it, but I'll keep the modified version and just delete everything here. And basically, this is just a new weather data, modified weather data, and I use the LadyBug import e+ weather data file, which is the same as you would get from just a normal weather data. So it's just this. I modified it and I get a new data set, but you don't need to go through all these steps here. Now, this is still an old import weather data. I could change that if I want. I could change it to the new version. Let's do that so everything is correct. So we make sure we are really in 1.8. Now, we talked about the UTCI, the Universal Thermal Climate Index. That's the abbreviation. And what it really is, just in very simple terms, is the perceived temperature. The perceived temperature is a mix between the temperature, the humidity, and the wind, the three things. And we also discussed that there are different ways. There's also the pad comfort, which is a more elaborate version. But let's look at the outdoor comfort, but this time in combination with the 3D model. Because we only looked at the outdoor comfort based on the weather data without any model. Imagine there's nothing on your site. It's only a blank surface. There's nothing there. That is the outdoor comfort without any 3D model. But now we have a 3D model, and it makes things more complicated. So, but how could we go about? And just as a reminder, we were here in view analysis, and now we get into this zone here, the human to sky relationship, and that where this becomes interesting. where this actually has something to do with the outer comfort. And I told you when we talked about the outer comfort that we will always go back to it and have a look again, because the outer comfort is probably the most interesting analysis within Ladybug, I would say, or one of the more interesting, let's say, for me at least. Now, that's a weird bird in the background, but they're birds. Nice. Okay, we're not starting here, but we're starting with the Ladybug UTCI, and we can plug this here. We put this here, and the UTCI is normally always an outdoor comfort. It's not indoor comfort. Okay, in the past it was very clear. We just plugged in stuff from weather data and that we got the comfort. But this time we have a model. Let's see how that works. So air temperature is equal to the dry pulp temperature. You can use that. We have the mean radiant temperature. Now that's more interesting. As you remember, we were able to determine that with the Ladybug Outer Solar mean radiant temperature. Right, let's put this here. We need this. And again, as you know, there's this underscore at the beginning, means you need to have an input, underscore at the beginning, at the end. You require an input, but there's a default, and you could not use that because it says here default is the same as the air temperature. But because we have a 3D model, we need an input here. So we need this thing. We also need the relative humidity. This goes in here. Wind velocity, this is the wind speed, and UTCI parameters. We can look at that later. That is very, very optional. And then we need, of course, a toggle, as usual. Toggle, run, toggle. And if we run this, we already get an output here. And now we cannot see anything, what that actually means. So we would need to go here. Oh, where's Ladybug? Here. And deconstruct the data from the headers. And we can go in here. And we can go in our values. And we have the perceived temperature for every hour of the year. It's a list with 8,760 values. And we get the temperature. It's very mild. It's super mild. It's very comfortable, really. I mean, it's always between 20, 21, 24. It's a very nice climate, really, to be honest. Now, if you want to see an average, we could calculate an average of these values, and that would be around 14. Now, imagine these are also the hours in the night. But yeah, overall, it's a very comfortable climate, I would say. Now, of course, if this is a different weather data from somewhere else, might be not as comfortable. Now, how can we bring the 3D model into this whole game? With the mean radiant temperature. So here we have this tool. Now, this tool can add more. It adds more detail to this outer comfort, to this very simple outer comfort calculation. First, we need the location here. We need surface temperature. Again, this is a bit vague because we don't have really any surface temperatures available. The diffuse normal radiation, we have that. This is here. We have the direct normal radiation, the diffuse horizontal radiation, and horizontal infrared. We also have that. Now, what we don't have is the fractional body exposure, and now we can see the what we need here, and it says a single number between 0 and 1, or data collection for the fraction of the body exposed to direct sunlight. The Ladybug Human to Sky relationship component can be used to estimate this input for a given set of context, geometry, and position of the human. Basically, so we can use this tool here, the human to sky relationship, that also requires different things again. So, but if we keep it very simple, we could now check here sky exposure. Again, this is the same. We need to have actually this Ladybug human to sky relationship component, but these are optional, as you can see, they're optional. And then the ground reference 0.25, so you could reference a soil. I would say the outer 0.25 is actually pretty accurate, I would say it's gonna be soil and vegetation mainly. And then the solar body parameters. I think we talked about this in the past, but we can also look at that, of course. We also need a toggle again and place this in here, and they actually ran, and we can use this now. So we could take the MRT and place it in here. I would love that the MRT input is on the end here. That would be nicer, so you don't have overlapping lines. But yeah, it is what it is. Okay, let's talk about this. The human to sky relationship. This human to sky relationship allows to input objects. First, again, we need the location. We need position. That's interesting. So we could argue that we have one position where the person stands. Then this position will be part of the analysis. But we want to, of course, check the whole site. So how can we do this? So we could create a grid. Let's generate a mesh, and so we need this here, the LadyBug generate point grid. We can use this, by the way. It's not mandatory. There's other ways to do that, but we have that already, so that's great. And now we can grab all our surfaces here. I'll take all the exterior surfaces, including the roads. I don't include the vertical. I think that should be all. Hopefully we can place here surface. That should be fine. Interestingly, I missed something here, so I can manage the surface collection and add if possible. Let's see if I can do that. Add item. Oh, because these are multiple surfaces. Okay, let's do that differently. We can turn off all these buildings here. Maybe that's easier. Yeah, we can do this, and we can place this in here, and we need a grid size. My project is in meters, so I can place here 1 as a minimum, or let's say 0.5 as a minimum, just to be on a safe side, and then 10 as a maximum. And normally at the beginning I would choose a higher number so we don't run into any problems. But now you can see, okay, it's created these points. Now, because my geometry is not as simple as a normal flat rectangle, it actually has a bit of an issue with creating these grids. But as you can see, if I make it smaller, you can see that it actually has a quite nice grid on it. Here's a few things where it becomes very dense. You can keep it like that, but probably, yeah. So there's some limitations. There's always workarounds, of course. But yeah, I'm happy with this. I'm fine with this. Now, the points, these are my positions. These are the positions where I want to measure the perceived temperature, the UTCI. So the points, the position. Location is the location of the project. The position is the position of the person on the site. And I want to test all these positions. So I can put this in here, and again, I put here 5 just for now, so I have less points. There's actually 2,853 points. It's a bit crazy. Not sure why. Maybe I can remove some of these. Don't have. I think this is the circles mainly. Or what I also could do is to test these first, only on the upper level. Nah, it's fine. Let's go with it. Maybe make it bigger. 6,000 points. Really? 3,000. Right. Yeah, we will just try it. Of course, you can always keep this very simple if you want. Just show you how that would look like with a more simplified surface. If this would be my surface, then you would have a very simple grid. Anyway, we keep this here. Now we also have a context. We can turn this back on. The context, buildings. But you can place anything in here. You can place the whole model in here. That's maybe even better, because then we know how these walls maybe influence the outdoor comfort. So I could take everything, create another BWrap container, and place this in here, and this is my context. Now I'm a bit afraid that this will now completely break my computer, so I will just put here 10 for now. Just cautious. I'm just cautious. You can refine this here. I think let's leave the other values. Oh, we leave the other values. They have default levels, but you can just go through and read through, like hover over it and read through what that does. And height is the height of the person. Normally, for example, heat is not equally perceived everywhere the same way on your body. It's on your face probably more perceived stronger than somewhere else, and that's why we have a height here. The height where it is will be measured. Is it on your face, slightly above? You could, of course, you could modify that to the average person's height in this country or in this location. The CPU count has something to do on how your computer is calculating this. Normally, as a default value, one CPU remains always to do any other task on your computer, so it's not crashing your computer. And we have a run button again. By the way, somebody had a comment the other day saying that I talk too much. Yeah, if I wouldn't talk, then you wouldn't understand. But you cannot make it right for everyone. So that was actually fairly quick. Although we have these 3,260 points, we could potentially look at this. I have never looked at this really. So we could generate a heat map just to see the LadyBug Human to Sky relationship for each point. So we have here values in here. They correlate exactly with the amount of points we have. Is the 3,260 values, and that actually could give us some indication of the human to sky relationship. The same with the fractional body experience, although here it's still something not right, but we will go through that in a bit. Human line, this is basically just shows a human person, like the height of a human, and the human points. These are the points here, which we then can use in here. Anyway, now as you can see, let's try this. Never tried this before. We could use the heat map, spatial heat map, to actually look at this data. This has nothing to do with the outer comfort, by the way. This is only the human to sky relationship. We have values. We could use the sky exposure here. Look at the sky exposure and the mesh. We have a mesh. This one. And now, of course, that doesn't work for whatever reason. Yes, it's very good that this happened, because so we need to make sure for the heat map. The heat map is very simple, but it needs exact values. So we have, from the sky exposure, we have 3,260 values, and the mesh gets only 62 values. That means we have used 62 separate surfaces. They generate different meshes. That's not what we want, of course. First of all, we could flatten this here. Now that will also require this to rerun. It's not ideal, but let's see how long it takes. Okay, that worked pretty fast. All right, okay. It didn't really change much because it already flattens it here. That was a stupid idea. But what else could we do here? Okay, now this we don't want to change. So I want to, if I change now the mesh, if I flatten the mesh here, it will rerun again, because this tool will say, oh, you changed something here in here. That's why I need to rerun everything. So what we're gonna do is we take the mesh and join the mesh. We join the mesh and flatten it. I hope I can, let's see. No. Okay, flatten. Now we're talking. So I had to flatten the meshes first and then combine the meshes. So we get one mesh with 3,260 faces, and that correlates with the 3,260 values going in here. All right. So very important. The meshes, because we have more than one mesh, we have to first flatten these. We flatten whatever comes in here, and then we join the mesh and flatten it again. I actually don't need to flatten it again. It's already done. So this mesh is the final mesh, and we can use this in here. And now this turned gray. That means it worked. Now we have this weird overlap. So let's just take everything off. And okay, we need to hide these points because of course we don't want to see that. Again, we don't want to see this. Turn off the preview of this. That doesn't mean it's not running. It means that it's not showing. What else is here? Something is not right here. Okay, let's do it like this. The mesh we also flatten. Preview. Now we're getting there. So we don't want to see all these things. That's also off. Okay, now we're talking. Okay, and let's turn on these so we have a bit of a reference here. It's pretty red everywhere. What does that now mean? So what it means is that we have 0.99 as a factor for this human to sky relationship. So we calculated how likely is it that you are exposed to the sky. And within here, you see there's a bit less. You're not 100% exposed to the sky in some areas. Like when you're inside, then it's completely blue. That means it's 0%. Or 0 as a factor. Alright, that has nothing to do with the outdoor comfort yet. The outdoor comfort is something entirely different, but it has something to do with it, of course, because the shadow indicates, will have an influence on the temperature. So I can take this off. It's good to see because we will need this later on, this mesh, to combine the mesh. We will need that again. So it's good to have that. Now we can add this here. We can add here the sky exposure. Now this will run again. This also needs to run again. Instead of just one value, one location, now it calculates 3,260 locations for each hour of the year. So that's a bit of a tricky bit. So it might take a while. Of course, it completely crashed, and it's also my fault. First of all, I didn't check how many surfaces are in the model. I realized, okay, I actually had too many here. And I also want to simplify here. So of course, just very quickly for you to understand. So we had about 3,260 values, and then we would go into the UTCI, which basically calculates the UTCI for each of these points for every hour of the year, and that completely crashed my computer. That would mean 8,760 times 3,260 values, which of course that wouldn't really work. So my computer crashed and I need to find a different way. First of all, being more careful on what I select. As remember, we had way more points here. Now looking at this, I have 890, which is way different. It's much less. It seems like there was some double overlapping surfaces and so on. But it is always good that this happens, so we always learn through mistakes. And then the funny thing is, if I select all this here, I have way more surfaces than I'm supposed to have, which is also interesting. So for our context, I actually do it a little different. I only choose these buildings here for now. Let's try it again. So I have these buildings separately, and I can always add my landscape if I want to the context. So I'll put this in here for now. Let's keep it more simple, and it will be much easier. I still want to hide everything. Don't disable, just don't show. That's the difference. Here, preview off. I want to also hide this whole thing. It's a bit weird now, of course, because we don't see anything. But okay, we have all our positions. And maybe keep this on for now so we see it. Okay. Context and the surface we want to test. And I missed something here. So I need to go back and add this to the list here. And you can always add things. Okay. Now it's added to my list. And I don't have the walls in here, but that's fine. I think that made a huge difference with the amount of points. It's fine. We leave this out. I want to show you the principles anyway. We can add it later if we want. Now, this points. So we calculating the sky exposure that we looked at before. Let's do this heat map again. Now we have it here already. We need to flatten our mesh. Flatten. And now you see it's much faster now, which is great. So the mesh is flattened. We have our sky exposure values, which we can put in here, and our mesh would go in here. Oops, no. We need to join the mesh, and now you can see it was calculated way faster. It's much faster now. Nevertheless, so my big mistake was that I took this. I need to, of course, put this in here, and I need to copy this again. So I crashed, and that's why I want to directly show you why, so you don't have this, you run into the same problem. I can also turn this off if I want. These are my points. I can turn this off. The points are not gone, they're just hidden. And now my big problem was that I placed my points, sky exposure, into here. Now what that does, it's creating a mess, because I have here additional 800 points which need to be calculated for each hour of the year. That's the big mistake. And with now much less points, it probably is okay. And of course you can do it because you also want to check the average outdoor comfort. But now we have two options. Either we reduce the points, that's possible, that's one option, so we can have less points. Of course, that, and again, it takes to calculate. Not much has changed really. I can turn this off. Still 1160 points, of course, but I can reduce the points by making the grid size bigger. Or, and I could actually use here the quads only. That's interesting. So we could try that. I can turn this off for now. Turn this on to see this. You could place here a toggle, a boolean toggle, and say true, quads only, and see how that changes it. Nah, that doesn't work. For that, surface is not simple enough. For that, we will need something else. Anyway, let's continue here. So we have our points, we have our mesh, that's fine. We try to lower it, but we still have quite a lot of points, 1160 points. It's interesting because it feels like we had less points with the grid size 4. Very interesting. 896. I think it's something related to how the mesh or how the surface is generated. For example, if I put here 5, actually see the distance become bigger, but I have more points. It's something weird going on. Maybe it has something to do with adding more points in here. Maybe that is the reason. Nevertheless, we keep it like that. We probably need to model the surface better. But yeah, sometimes you don't have that option really. So what else could we do in order to minimize that? Because it doesn't make much difference. So if I now look at this here, my values overall will not change much. So if I say, for example, average, the average value is 17. Now this actually has changed because we added this mean radiant temperature. We didn't use that before. It's quite interesting. That actually had a bit of influence on the output. But imagine we would now test this site, each point, the average per year, the average outdoor comfort might not change much. So where this actually makes much more sense is to test the outdoor comfort in a specific time of the year. And we could now, what we could do is we could limit the data set, the data, to a specific time. So you know that from before, we could have an analysis period. Now there is no way to put an analysis period into here. So what we need to do is we need to limit the analysis period before it actually goes into these two analysis tools, which makes it better anyway because we already limited before the calculation happens. Otherwise, calculation would happen and then it would limit it to a certain time, to a certain period, which we don't want. So actually what would be good to test, just let's start with one day, one specific day of the year. Now how to do that, we can go in here and say apply analyze period. So we have this and then we apply that period onto the data. So for example, we have the start month is 1, let's say 30. No, sorry, 12. Start month is 1 to 12. You can see here it's 1 to 12. Okay, let's take June as we are. Oh no, July. We're in July now. End month is also July, and we have the start day from 1 to 31. Let's take today is the 14th, and today is the 14th, and And that's what we do. Let's test the whole day. Let's test one day. This is my period now. We're testing one day. We test only the 14th of July, but we test all the hours of that day. So it's like 24 values, indexes. It's in the index of these specific dates. Now that period goes into here in this tool, and then we can apply this to a data. For example, here the horizontal infrared data. We can put this in here, and instead of using this, we're gonna put this in here. Now it turns red, of course, because we have different amount of data points than in the other data sets. So we need to do this for all of them. Diffuse horizontal infrared, so diffuse horizontal radiation. Then we need the dry bulb temperature. It's the same here. This was relative humidity. We missed this one. Direct normal radiation. This is here. Now this, see, it's already gray. That means we solved the problem of having different amount of data points. Surface temperature is also done. And here's still some problem. The wind velocity is not correct. Wind speed, it's a bit messy. There are other ways to do it. You could link all data sets into one of these, apply analysis period, and then choose a list with the human list selector. That's also possible. So you could put this in here, then you could choose here whatever you want. Probably better solution, but that's how it is at the moment. There's always a way to improve it, of course. Let's try to make this less messy here. Now, for this human to sky relationship, we don't have any, it doesn't change with over time. It's always the same. It's it could change, of course, if you have plants which change over seasons, then that might change it. But we're testing basically the geometry of the buildings with the landscape, and that really doesn't change. So therefore, we can just place this now in here. And just going back here, you can see that there are now only 24 values in there, from 0 to 23. And it's very similar still. So this is now calculated in June the 14th. And we get the UTCI. But we haven't yet attached the information about the building. So this sky exposure is still missing. So we need to place this here, sky exposure, and yeah, I'll save this just in case, you never know. Sky exposure, and also this one. Costs a lot of time when it crashes. So that's why better save your stuff, save your work as much as possible. Okay, now we can use this here. Oh yeah, we need to run it also, of course. Now this is a very, very different list now. Because what it does, it goes through each point, and then calculates the average. And in that case, it's always pretty much the same, but slightly different. That's where actually the building has an influence. The building influences the outer comfort. So we could go through here and see how much that changes. See, there's like 1-2 degrees difference. It's not a lot. It's not really a lot. And now, this is pretty cool already. A single number between 0 and 1, or data collection for the fraction of the body exposed to direct sunlight. So we can now also add this here, the fraction body experience. But this, I don't think we can just place this in here. This is a bug since ever. Yes. Now the problem is the output here is not resolved. We actually need to have a look what's in here. There's something wrong. I don't know, I always hope that they will change that, but it hasn't really changed ever. It's one list, but there is a header and there is a number. So we need to use our LadyBug deconstruct data set. Also doesn't make sense, really. Let's flatten this. I will delete this here. Need to see how that works. Oh yeah. Okay, turn this off. Okay, let's fix this first. There is something not right, and I want to show you, because otherwise you're gonna send me a message and say I don't understand how it works. Let's have a look. This tool is really useful when you just don't understand the structure of a data set. We can change this to draw a tree. Interestingly, there's only one list in here, but I can see that that's a list within a list. So how could we fix that? Because the only thing we can put in here is a number between 0 and 1. And at the moment, it's like a list of lists. So we could probably average the output. Let's see if we can do that. No, we cannot. Let's do it like this. I use this because then so I separate the data from here, because so I can work with the data without affecting anything here, which then influences this. So it's a chain reaction of calculation. And I only want to work with the data here, and I want to see how can I fix that. And I did this in the past, I just forgot how it works. So if I would simplify this, what happens? If I flatten it, yes. If I flatten it, I only get one list with a value and a data. That's why. So flatten this here. Now I can do what I wanted before to separate the header from the values. No, that's not how it works. I don't understand why there's so many in there. Okay, let's not flatten it. I think that's what we need to do. Yes, now it makes more sense. Okay, and now we flatten this. Okay, so I realized that in here there's a list within a list, and that cannot be fed into this here. That's impossible. You can only allow one list with numbers between 0 and 1. Now what I took is, I took the data, I separated the header from the values. So that was another problem. I cannot have headers and values in this here. And I'm not sure why they do it like this. There must be a reason. It says here, it can be plugged into the solar MRT components in order to account for context shading in the computation of mean radiant temperature. But that doesn't work like that. So that's where probably a lot of you then say why it doesn't work. Again, we have the data, there's a list of lists with headers. I separate the headers from the values. I keep the lists within because there are 923 lists. I calculate the average for each list. So if I flatten this, I get a list. I get 923 lists with one value in it. Now I can then flatten this, and that gives me a list. It's giving me a list with a value from between 0 and 1. Again, it needs to have the same amount of values as points. I need the same amount. So here I have 923 points, and I have here 923 values, including 0, by the way. 0 to 922. Okay, that's good. And that now I can place in here. And that hasn't run yet, so I can turn on run. I have a pretty bad cold, or I don't know what it is. Maybe I have an allergy. I never had allergies before, but it seems like I'm getting it. Alright, so before we did the spatial heat map for the sky exposure, now we can unlock this here. We still need to use the mesh. That's fine. But now we don't wanna check the sky exposure. We actually want to see the outdoor comfort. Now the problem here is, again, we have values. They are separated per input location. Now that doesn't work because we can only have 923 values. At the moment we have 923 lists of values. So we need, again, calculate the average of these, which is actually this. In fact, it's this one. And that needs to be also flattened, so it becomes one list. So for each point, the average outdoor comfort is a number. It's the average from the hours we're testing, between 0, like midnight, until 11 in the evening. So that's what we're testing. Can put this here. That worked. We can remove this if you want. And I think we should turn a few things off so they are not disturbing the view. So I can go back here and render the view. It's nicer. Turn this off here. Turn this off. And here we have it. I just want to show the buildings. Now, okay, of course you can also change the time, the hours. So let's try that. So, because in fact we don't want to know the average. We want to know which time of the day is really annoying and which time of the day is really nice. So we could go in here and we could put 23 as a maximum and 0 as a minimum. And then we can place here a start hour, maybe 3 in the afternoon until 3 in the afternoon, which is like that hour, 3 in the afternoon. Start time, now it's of course calculating again, but it's gonna calculate faster because it's less points again, it's less points to calculate. You can still of course calculate the average here, which is 22, which is pretty good. 22 degrees I would love to have, but it could also become a bit boring, honestly. Sometimes I like it when it's cold outside. Yeah, so this is one way to determine this here. Now, how can we analyze a bit more? What can we take out of this? Is there another way to look at it? And I mean, we haven't really, because we used some components from Dragonfly, but if you have weather data which is very close to your site, then you could analyze something which is called the design days, which gives you a more design days. Basically are days with a very average kind of data set. They are very average for this specific location. There are also statistic files. There's also a statistic file in here in the weather data. We could produce that. We could actually create a modified version of it. I will not show that now, but I want to show that you could check here, for example. Let's look at design days. I mean, we looked at this before, but design days, what's in here? So in here, the design days which you can use, which have a certain property. So that's one way to understand a bit more about your site. And then the other way is to look at the stats file, the statistic file. This is really interesting because in the statistic file, you can get days where, well, first of all, the statistic file has pre-calculated data extracted from your data set. It's again, you have the location, you have the ASHRAE zone, which you need for honeybee. You have the Köppen zone. This is the climate zone, which you also need for honeybee. And then the clear direction normal radiation is also used for honeybee. But then you have the heat days and cooling days. And then here at the lower end, you have something very interesting. You have a typical weeks, and you have extreme hot weeks and extreme cold weeks. So what you could do is then to check these. Oh, no, I didn't want that. So I can check what is the extreme cold week. And it says here, it's in November from the 12th to the 18th. That means I could check now, what does that mean in terms of how cold is that really? So if I can bring this over here. So I could test this extreme cold week or extreme hot week or typical weeks. The cool thing is I could use that as a period. I could take this, and instead of using this tool here, I could just place my cold week or hot week and so on into these periods. And of course now it would be better if this would be kind of streamlined better. So we could do this data. Let's test if it still works. Yeah, it still works. So now I could change the period from this one, this manual created one, to the cold week. And then of course it would be great to compare this so we know what we're talking about. 22 degrees in summer, and now I just place this here. Oh, that doesn't work. Yeah, it should actually work. Okay, let's try it. Yes, there's something wrong. Now we place this here, extreme cold week. Let's check. Yes, average is 14. It's a bit of difference. And then we could of course check the extreme hot week, 17, which doesn't make sense because, well, now it makes sense because we had this, as you remember, this is an average of the whole week and not just 1 hour. Now if you would then use one typical week, you need to be careful because there are actually two weeks in here. So you would need to decide what you're gonna choose. You could do that by select list item. So I have this, and then you select one of these, either 1 or 2, or you could use the list selector from Human. That's a really good one. So you could put this in here and then select whatever you want. Now I want to go back to my hourly dataset and just test here a different hour of the day. And it's a question if then does it really matter anymore, because if the sun is still up or not, yeah, it doesn't really change much. Now, one more thing I want to do is I want to add the whole model really to my context, because that might influence this a bit more. So I can go back here. Of course, it was a mistake now. Let's do it like this. Now, it's also interesting that, okay, everything's of course red. Now we could play with, of course, the colors of this heat map, because you would argue that blue is more comfortable, but actually it's quite comfortable throughout, and 19 is actually really comfortable compared to 17, which is a bit colder, but not much. So overall, it's quite decent. Nice temperatures. And of course, now you could test completely different environments. Sweden or Norway, where it might be very, very different. And that's how you do the UTCI, the perceived temperature, outdoor temperature, in LadyBug Tools 1.8. See you in the next video. Ciao.